Hello people, so today we'll be solving LeetCode daily question that is 2699 modify graph edge weights. But before that, please subscribe to the channel, hit the like button, drop a comment, give me any feedback, any suggestion which you would like to give. And without wasting any time, let's just dive into the video. And this will be given an undirected weighted connected graph containing n nodes labeled from 0 to n minus 1 and an integer array edges where edges of I is equal to ai, bi and wi, indicating that there is an edge between nodes ai and bi with the weight wi, and some edges will have a weight of minus 1, that is wi will be equal to minus 1, while others will be having a positive weight of wi greater than 0. And our task is to modify all the edges with a weight of minus 1 by assigning them positive integer values in the range of 1 2 1 2 2 2, 2 into 10 to the power 9, so that the shortest distance between nodes and source becomes equal to the integer target. And there are multiple modifications that make the shortest path between source and destination equal to target. Any of them will be considered correct. And we have to return an array containing all edges, even unmodified ones, in any order if it is possible to make the shortest distance from source to destination equal to target, and for or an empty array if it's impossible. And we note that we are not allowed to modify the weights of initial edges with the initial positive weight. So for example, this is not the array, but in the given test case all of these weights are considered to be minus 1. Okay, and we need to make our target equal to 5. So for that what we have done is our source is 0 and the destination is 1. So we have made this path is the shortest path, and by assigning 0 to 3 a weight of 3 and 3 to 4 a weight of 1, 4 to 1 a weight of 1, the target is achieved, that is of 5. Other possible way could have been we could have assigned this to this weight of this as a weight of 2 and this as a weight of 2 and this as a weight of 1. Again, that would also have been a possible solution. And if you will have a look at the next test case, to we have to make the path from 0 to 2, and we are having the weight mm, okay, and in this we are having the source as 0 and the destination as 2, but there is already an edge with the weight of 5, and we don't have to change the weights which are having initial value as positive, and so there's no other path by which we can reach to. So in this we have to return an empty array no matter if there is a path reachable from 0 to 2. Okay, so for this we'll have to use Dijkstra twice. Firstly, we'll be marking all the negative weights as 1, and then we'll be finding the shortest path, and I'll be updating the values in that particular, like in this path, with the current value minus the total target, so we'll be having our answer value. Okay, so let's have a list of integer array, and let's call it graph, basically a array of list of integer array. So of new array list of size n, ah, we don't need this. Okay, so let's just fill in the graph. So for int I equal to 0, I less than n, I plus plus, graph of I equal to new array list. Then for int I equal to 0, I less than n, I less than edges dot length, I plus plus. What I'll be doing is I'll be marking the edges. Sorry, first let's have u that is equal to edges of I 0 and v that is equal to edges of I 1, and let's now add. So graph u dot add new integer array with the node v, and currently I'm storing the, let's say, the weight as I, because the node to the ith distance basically. Here I'll be doing v and here it would be u. Okay, so now let's have a distances array, and this that is equal to new, it's going to be 2D array, new int of size n cross 2, uh, basically for checking if the positive weights and the negative weights. Then I'll be filling every of this for int I int dist arrays dot fill I comma with maximum value, integer dot max underscore value. Okay, and then we'll be marking the arrays dot fill. I'll be using it again. The distances of source source should be equal to 0. Okay, now what I'll be doing is I'll be calling the Dijkstra method, and here I'll have to pass some other values. Firstly, the graph, edges array, distances, my source node, and the parameters that are the current difference, which I'm considering to be 0, and the leftover, which I also am considering to be 0. Okay, after, let's just quickly write the Dijkstra algorithm first. That is private void Dijkstra, and this I am having a array of list of integer array. So int array graph, a 2D array of edges, int edges, again a 2D array of distances, the source node, my current difference which I have to consider, and the run value. Basically, that is the with which I have to run, because considering by now I am considering that I have to take the weight as 0. Okay, so let's have n that is equal to the graph int n that is equal to graph dot length. Okay, now let's to do the Dijkstra we need to have a queue. So int array queue, let's call it bfs, that is equal to new priority queue queue. So here I'll have to pass a custom comparator, that is comparator dot comparing int with a sorry, if I'm having a of 1, basically based on the distances. Okay, then what I'll be doing is I'll be adding the source to the queue, bfs dot add new int of src, and the weight to reach the src is 0, and I'll be setting that the distances of dist src run, that is also equal to 0. Okay, so now while not bfs dot is empty, what I'll be doing is firstly I'll be polling the current, so that will be equal to bfs dot poll the node I'll be having, that is equal to current 0, and the distance okay, let's call it distance only, that will be equal to current 1. Okay, now what I'll be checking is that if my distance is greater than the distance which is already present at that particular node, so node run, in that case I have to continue, because there's no way I can find a smaller distance by this. Then for I'll be traversing the children of that particular node, so for children in graph node, what I'll be fetching is I'll be fetching the child, so that will be equal to children 0, the index of the edge, basically which we stored over here, I and I, sorry, that will be equal to children 1. Okay, and now what I'll be doing is I'll be fetching the weight, that will be equal to, so let's fetch the weight, so that will be equal to edges ind 2, or we could have just stored directly the weight, that's also possible. So I'll be checking that if w is equal to -1, I'll be setting that I'll be currently initializing that my weight is equal to 1. Okay, then I'll be checking that if I am running the algorithm when I'm considering it 1, and my edges of index 2 is -1, so I'll be having the new weight new w, let's say that will be equal to my difference, which here I'm considering to be 0. Basically difference is the value which will be I'll have to calculate after I'll be running after the first time running the Dijkstra. So here I'm considering that okay, my difference is this is 0. Basically firstly I'm forming the path, and after that I'll be assigning the leftover values from the target to the other edges. Differences plus distance of child 0 minus the distance of node 1. Okay, and then I'll be checking that if new w is greater than the weight. Okay, in that case I'll be updating the edges of index 2, that will be equal to weight, and also that will be equal to sorry new weight, and my weight will also be equal to new weight. Okay, and after this I'll be checking that if distances of my child node and the run method, if it is greater than distances at node run plus w, in that case I'll be updating the distances of child run with this, let's just copy and paste. Okay, and also I'll be adding it to the bfs dot add new int child comma, I'll be pasting this. Okay, so this is how our Dijkstra will work. And now let's come back to the main function, and after first time calling Dijkstra I'll be calculating the leftover weight. So I'll be having the value difference, so that difference comes from here, so target minus distance of destination 0. And here I'll have to add some check that if difference is less than 0, that means we cannot reach there at any point. So int I have to return an empty array, empty matrix basically. Okay, then I'll be calling the Dijkstra again, Dijkstra again, graph edges distances source, but here time I'll be passing on the difference and my run value will be 1. Okay, so then I'll be checking that if distance of my destination 1, if it is less than the target, so in that case also I'll be returning a new int empty matrix. Okay, otherwise I'll have to return that. Firstly I'll be traversing for int edge in edges, and I'll be marking all the negative all the edges that are having negative weight to 1. Okay, so if edge of 2 is equal to -1, okay, I'll be marking the edge of 2 equal to 1. Okay, and at the end let's just return edges. It was a long video. Now let's give it a run. Okay, so not a statement return. Now let's give it a run again. You're not find Dijkstra. Okay, Dijkstra. Any more errors? Okay. Now let's give it a run again. Yeah, and it gets accepted. Now let's submit it. Okay. Yeah, and it works probably fine as well. Okay, so this was today. Thank you for watching.